Hi, this is video 2 in the playlist where we're looking at a past sample paper. This is the sample assessment materials, and it's the calculator higher tier Edexcel paper. And if you follow the link below in the description, you'll be able to download this paper and have a go at the questions for yourself. We're going to be starting from question 8 onwards, and if you are able to stop the video, have a go at each of the questions, and then compare your solution with the solution that I write out. It should be round about 20 to 30 minutes worth of video, and hopefully that will give you a focused 1 hour revision time. Okay, so let's have a look then at question number 8, which talks about a box of pens. Okay, this is really just working a little bit through with a little bit of algebra really. It's fairly straightforward, but the difficulty with it is always reading this bit of information and making sure that you're up to speed with this bit of information. Okay, so in a box of pens there are red pens, green pens and blue pens. Okay, so forget how many there are of each, but there's going to be red, green and blue, and they're all on some sort of ratio. And really the way of working this through is to kind of keep reading it through until you find one value, in this particular case blue, that we can write as X. Okay, so that's an unknown quantity, and it's the, if you like, the core quantity, it's the base quantity, and everything pins or hangs off that value of the blue pens, because what it tells you is that there are 2 times as many green pens. Well, if that is the case, then that would be 2x, okay, and then there's 3 times as many red pens as green pens, so 3 times 2 is going to be 6 lots of x. Okay, so that's the key ratios, and actually for this question we can write that out simply as a ratio of 6 to 2 to 1, and that's all we need for this type of question. Okay, hope that's all right for you. Let's move on now to question number 9. Now, question number 9 is on the surface of it relatively straightforward, but what I think would happen with this is that you'd see one of these trapeziums and automatically start to think about that you need to work out the area of this, particularly because they've given you this value of h, which actually in this question you don't need. Okay, what you've got to do is make sure you read the question. The perimeters of the 2 shapes are the same. Now, yes, they are going to ask you to work out the area of the rectangle, and that's the final bit of the question. However, the important thing is, in order to work out this area of the rectangle, we just need to work out the value of x first using the perimeters. Okay, so what we're going to do is we're going to calculate x using perimeters. Okay, now I'm quite keen sometimes on just repeating the information that they've given you in the question, because I think it does help you a little bit to focus on the information that you need and what they're trying to get across. And they will sometimes throw you a bit of a curveball by giving you these bits of information that sometimes are not required. Okay, so let's have a look at this. Now, we do know the rectangle is equal to the trapezium in terms of the perimeter. Okay, so what I'm going to do is I'm going to imagine if I'm working out the area of the rectangle, well, I'm going to start at corner A. I'm going to go 3x plus 4, then I'm going to go 4x, then I'm going to come back again 3x plus 4, and then I'm going to go 4x again. Okay, so if I write that out, the rectangle is going to be 3x plus 4 plus 4x plus 3x plus 4 plus 4x. Okay, now it does look a little bit untidy at the moment, but if I gather up all of those like terms, what I end up with is 3x, 4x, 3x and 4x. Add all of those together, I'm going to get 14x, and then add the numbers up, I got 4 and 4, which is going to be plus 8. So a simplified version of the perimeter of the rectangle is going to be 14x plus 8. We need to do the same with the trapezium, okay? Not so much different really, it's just a case of working it through. So I'm just going to move that up a little bit, and again I'm going to start here, go along here, x minus 3, 5x, 7x minus 3, 5x. Okay, so if I write all of that down, I've got x minus 3 plus 5x plus 7x minus 3 plus 5x again. Okay, so then I need to just simplify it, make it look a little bit more or easier to work with. I've got my x's, 5x, that's 6x, plus 7x is going to be 13x, plus 5x is going to be 18x, okay? Then I've got my numbers, I've got minus 3 is minus 6, all right? So using this balanced equation now, it gives me the ability to find out the value of x, because if I take 14x away from both sides, it means on the right hand side I get 4x, and then I'm going to add 6 to both sides, and it means I lose this minus 6 here, and I'm going to get 14. So 4x equals 14, which means the value of x equals 3.5. Okay, so I can just simply take that value of 3.5 and work out the area of the rectangle by plugging it directly into here. Okay, so I know that the area of the rectangle is going to be the length of the rectangle multiplied by the height. Okay, so let's just have a look at that. So the length of the rectangle is going to be 3x plus 4, and that's going to be multiplied by 4x. Okay, so I know that the value of x is 3.5, so let's just put this in now. Again, I'm a bit of a believer in using kind of brackets and that sort of thing for these. Okay, so I'm going to put some big square brackets there. 3 times 3.5 is this value of x here, plus 4. Okay, and that's going to be multiplied by 4 times 3.5. Okay, now you can work all that out, plug it in your calculator, and you'll end up with 14.5 multiplied by 14, and that's going to give you then an area of 203. So actually the area of the rectangle is going to be 203 centimeters squared. Okay, so if you go back to reading the text again, it does tell you that all measurements are in centimeters, so centimeters squared for that one. Okay, I hope that's okay for you. Let's move on then to number 10. Okay, question 10 is one of those questions that deals with compound interest. They seem to be a bit of a favourite with calculator type questions or calculator papers, just really because you're going to be using your calculator a little bit more. Now with this one, there is a little bit of just playing around with this to kind of make sure you understand what it is they're going to do. But let's just have a look at it a bit at a time. So Katie invests £2,000 in a savings account for 3 years. The account pays compound interest at an annual rate of 2.5% for the first year. Okay, my best suggestion is stop there. Okay, just don't worry about anything else at the moment. It's 2.5% for the first year. So let's actually work that out. Well, that's going to be in the first year. Okay, it's going to be £2,000. Now I'm going to use the formula for this. Okay, what I'm going to do is I'm going to multiply it by the multiplier, which is 1.025, and that's the value of 1 because it's the first year. So at the end of the first year, she's got £2,050. Now, if you're not sure about how I've done this, I'll just divert very, very briefly to say that this is the same as saying 102.5%. Okay, well remember that percent means over 100. So that's the same as saying 102.5 divided by 100. Okay, now if I'm dividing something by 100, I move the decimal point twice, so that's going to equal 1.025. So basically that's the decimal equivalent of 102.5%. Okay, and I use that as my multiplier. I now know at the end of the first year she's actually got £2,050. What I'm then told is that at the end of the next 2 years she's got X% and X%. Okay, so so in the second year she gets X%, and in the third year she gets X%. So at the end of 2 years, okay, she's been given some degree of compound interest, which we're trying to work out. But what we are told is that at the end of that period of time, she's now got £2,124.46. Okay, so if we use the formula again, what that means is that she started with the original amount 2,050 multiplied by her multiplier, whatever that is, and we're going to work that out in a minute, and that's going to be squared. So I've used exactly the same formula as I have here, but in this particular case what I've said is that actually rather than ending with 2,050, which she did at the end of the first year, now at the end of 2 years she's ended with £2,124.46, and she started with 2,050. Okay, so let's just work that through. Well, if I divide through by 2,050, I get 2124.46 over 2,050, and that equals the multiplier squared. Okay, pop that into your calculator, and what you'll end up with is a value of the multiplier at 1.017, and so it goes on a little bit. Actually, I'm sorry, I've kind of not given myself a lot of room here, but that's the value of the multiplier. Okay, alrighty. So actually that answers the question, because what I could do is I could just check this, make sure that we're absolutely correct with that. So what I'm going to do is I'm just going to check. I'm going to say, well, in that case, to check this, okay, it must be that 2124.46 equals 2050 times the multiplier 1.01799 squared. And if I pop that into a calculator, actually, yes, it is absolutely correct. Okay, now don't forget that, as we mentioned before, this is the value of the multiplier after the percentage. It's the kind of decimal equivalent, so I need to work backwards by multiplying it to get the value of the percentage, the rate of interest. Okay, so if I work that backwards, I'm going to end up with actually 1.799%. So that's going to be the same as 1.799%. Okay, now if I go back to the question, it doesn't actually again give me any degree of decimal place, but what I'm going to do is I'm just going to make it very clear to the examiner that I'm going to write 1.8%, and I'm going to put that to 1 dp. Okay. All right, so it takes a little bit of working through that particular question. There is quite a lot of just making sure you've got confidence to be able to use this formula. You possibly could do this type of question using a table, but I think it might be a little bit hard work. So if I were you, I would have a look at some of the formula videos on the channel, and that'll give you a bit more practice with these sorts of questions. Okay, so let's go on to part B, and this is where Katie goes to work by train. Okay, it's nothing at all to do with the previous question, so you need to clear your mind from the previous question. And it says the cost of her weekly train ticket increases by 12.5%, and the new cost is £225. Okay, so work out the cost of her weekly train ticket before this increase. So what we're saying actually is that this £225 is equal to 112.5% of the normal price, because if it's increased by 12.5%, 100% of it was what it used to be, and 12.5% is what it is now. So what it is now is 112.5%, which is £225. Okay, so let's just, as we did before, let's convert that to a decimal. I end up with 225 equals 1.125. And I'm just going to put n, okay, so of in maths always means multiply, and rather than writing normal, I'm just going to write n. So I'm going to write 1.125 n. And that's really the mathematical statement I'm going to use to be able to then write out the solution to this by dividing through by 1.125. So if I divide that through, I get 225 divided by 1.125. So it means then that her normal price, very neatly in this question, was actually £200. Okay, now I'm very aware that you could have worked that out in slightly different ways. In this particular one, I kind of like the idea of having a mathematical statement, something like that, and using that statement to be able to then to answer my question. Okay, so let's move on then to question number 11, which is going to be dealing with working out the angle of x in a circle and a triangle and bits and pieces. Okay, I think the difficulty of these questions is that they can look a little bit daunting, because you've got a lot of information here which you know anyway because it's already on the drawing. So PT is a tangent to the circle. You can kind of see it's a tangent. Okay, you don't, well, I suppose you do need it written down, but it does make life a little bit trickier when you've got to kind of read all of these things. And then it asks you to work out the size of the angle marked X. Okay, and you must give a reason for each stage of your working. Okay, well, what I'm going to do is I'm going to divorce the two things. I've got a circle and I've got a triangle. So what I'm going to do is, if I look initially at the triangle itself, well, what do I know about that triangle? Okay, well, I know it's got the corners are called S, T and P, so I'm going to say that triangle SPT equals 180 degrees, and those are internal angles. Okay, right. Okay, so those are internal angles. So it's going to allow me then to work out a little bit of information about this, because if I want to work out what I've got here, so you can see here I've got part of it is this radius along here, and that meets a tangent, and you need to know that it meets a tangent at 90 degrees. Okay, so let's just have a look at adding angles together. Okay, so if I have a look at what is going on within this particular triangle, if I want to work out angle S plus angle T, okay, so I know this bit of it is going to be 32 degrees. So overall, because everything adds up to 180 degrees, what I can say is 180 degrees minus 32 minus 90, and this 90 is actually angle OTP. Okay, now if you want, you can put in there that it's where, and one of the reasons that you can give for this is that this is because it's a radius meets a tangent at 90 degrees. Now, unfortunately, with these sorts of videos, it's very difficult to be able to kind of write things out nice and neatly, but hopefully you'll get the idea that you'll be able to work that out for yourself. Okay, so what we're in then a position is that we know that angle S plus angle T equals 58 degrees. Okay, so this angle here, angle S, plus angle T, okay, is going to be equal to 58 degrees. Now the second bit of reasoning that you're going to need is that angle S and angle T are the same as it's an isosceles triangle. Okay, now if you want, you could draw a little bit of a diagram there. I think that might be a good idea. So we'll jot a little bit of a diagram there. What I'm going to say is that that and that, okay, they're both isosceles. It's an isosceles triangle because these are both the radius of the circle. So if I put in there both radius, okay, of circle. Okay, so this is really demonstrating to the examiner that you really do know what you're talking about, okay, and I suggest that your drawing is a little bit neater than mine would be, but it means then you can show the examiner that you understand that a radius meets the circumference at a radius meets a tangent at 90 degrees. You also know that this is actually an isosceles triangle because they're both radius of a circle, okay, so if angle S plus angle T is equal to 58 degrees, which is what we've worked out, okay, then we can say that 58 over 2 equals 29 degrees, okay, and we can put therefore angle X equals 29 degrees. Now it is a 4-mark question and I've not particularly drawn it very well, but if you spend a bit of time working this through and making sure that you demonstrate that you've understood the question, I've used shorthand angle S, but really you should be saying rather than S, you should be saying that it's OST, and if you look at the diagram that will show you how to do that. So I have used the shorter version for this, so it's not as neat as a 4-mark answer would deserve, but hopefully it'll give you some idea. Okay, so let's move on then to the final question in this particular video, which is going to be question 12, and again please do stop the tape, have a go at that. I'm conscious I'm up to 20 minutes, so I'm going to try to aim to get this to be about 30 minutes in length if I can, or less. Okay, so again, quite a lot of information in this, and very typically, and you see these questions quite a lot, they ask you to complete the probability tree. Okay, so let's just have a look at it in a bit at a time. The probability that a car is stopped by lights at A is 0.4. Okay, so there's my lights at A, okay, and I'm going to stop, so it's going to be 0.4. which means not stopping is going to be 0.6. Okay, then I'd go on to say that if I look at the next bit, if a car is stopped by lights A, then the probability the car is not stopped by lights B is 0.7. Okay, so if it's stopped at light A, the probability that it won't stop by lights B is 0.7. Okay, so put that in there, 0.7 and 0.3. So like a lot of these questions, it's a little bit of detective work to kind of sort things out and put things into the right way, and you do actually get 2 quite well-deserved marks sometimes where you can work your way through the English. Okay, so let's have a look at the last one. If a car is not stopped by lights A, so not stopped by lights A, the probability that the car is not stopped by lights B is 0.2. So that's going to be 0.2 and that's going to be 0.8, and that will give you 2 marks for answering that question. Okay, now it would be a good idea, and again you can go on if you wanted to read part B of the question, but I think just for the sake of completeness of this, before I'm going to go on, what I'm going to do is just do a little very quick piece of work on what they call outcomes. Okay, and if you're doing probability trees, it's always worthwhile just to very quickly write the outcomes. Stop, stop, stop and not stop, not stop and stop, not stop and stop, okay, and then not stop and not stop, because it's a fairly safe bet that when you actually get to the next bit of the question, it's going to ask you to work out some probability. Okay, so, and this is, I guess, just one of those things, you've got to kind of wade your way through. So Mark drove along this road. He was stopped by just one of the sets of traffic lights. So he could be stopped by traffic lights A, or he could be stopped by traffic lights B. So in other words, what we're looking at is these probabilities in here. And that's why I kind of wrote those out, because I figured that it would be much easier to actually have those available to me when I read the rest of the question. Okay, so this one here is where he was stopped at A. Okay, so this is where he stopped at A, and the probability here is 0.4 times 0.7. So he was stopped at A, and not stopped at B. So stopped at A, 0.4, not stopped at B is 0.7. Okay, so the next bit of my question is going to be where he was not stopped at A, but he was stopped at B. So not stopped at A is 0.6, this is 0.6, and stopped at B is going to be 0.8, so that's B. Okay, so if I now put those two bits of information together, I can then rewrite down here, so stopped at A, okay, and the probability of him being stopped at A is 0.4 times 0.7, which equals 0.28, and the probability that he would be stopped at B is going to be 0.6 times 0.8, which is 0.48. So in other words, actually, he is much more likely to be stopped at B. Not quite twice as likely, but fairly likely. So I'm going to put just a line in here. These three little dots mean therefore is more likely to be stopped at B. Okay, so I hope that's okay for you. That's going to conclude this particular video. This has taken us up to the end of question 12, and from the next video we're going to be working through from question 13 onwards. Please do compare your solutions with the solutions I've given here. If you're not sure about anything, please add a comment below. I'll always come back to you. Subscribe to the site. I'll look forward to seeing you inside the next video.